Thank you very much. Thank you very much, Maria. How many time I have?
I'm afraid to say again, you can talk as much as you want.
First of all,
at least 20 minutes.
Okay. First of all, I want to thank you to all our Serbian friends for the hospitality. I can tell you it's 17 years and when I come in Belgrade every December, and it's a great pleasure. And we developed a very good relationship together with the Serbian Association, Serbian HVAC Association, and we have together results. We promote this area in Riva, and also we promote this area, Balkan area, our knowledge in ASHRAE. We have more than 12 years then we open a chapter in Timișoara together. Professor Branko Todorovic and Professor Florea Chiriac was the people who developed this association. Thank you very much being here, the representative of ASHRAE, and we can show you direct what we can do together and how we can promote our field. 2 years ago, I show you here in the Congress. I showed this school which was under construction 2 years ago, and now we are on the stage to show how this school works. My companies work from 4 years in Belgium, and one of our contract was this building. It's an exemplary building. I cannot see how to. Okay. It's working. It's okay.
Thank you.
I will use my computer because I am in direct connection with building management system of this school, and to show you how it's working. Before to start, because I was vice president of Riva from 9 years, I want to see some words about Riva. Riva, it's a professional organization representing more than 100,000 engineers in building services, and we have in Riva 27 European countries and associations. For the moment, I'm in charge with the Clima 2019 organization, and I'm Riva ambassador for Clima 2019. Okay, let's jump and to explain once again what means an exemplary building. An exemplary building is a building that has remarkable solution to a series of criteria regarding sustainable building, and this in a larger sense than just energy-related question. Thus, an exemplary building is made to be more energy efficient, passive standard, present the lowest environmental impact in the wide sense of the term, construction, use, demolition, ensure an exemplary comfort, visual, thermic, acoustic, ensure a good water and waste management, encourage biodiversity on the site, have a great architectural quality, and use reproducible and profitable solution. Small mention here, this building won in 2012 an architecture prize, and if this building was controlled under execution and also in use, and it should achieve some requirements, and the states of the city hall of Brussels give some subsidy for this building. The project for Le Trèfle Community School in Anderlecht is characterized by progressive, energetic, and environmental achievement. which easily meet the passive standard. Research indicates that the round shape used in the project stimulates movement, resulting in a potential average increase physical exercise of 20%. The complex style of this shape improves interpersonal relationship and also offer an interesting architectural statement for the neighborhood of which the development is moving ahead quickly. The building and electrical installation are all aligned with another in order to achieve an optimal energy consumption, water management, and indoor climate. The outdoor area around the school has been designed as a natural structure. Vegetables, gardens, green facade and roof ponds. Sustainable water management is achieved both by retaining rainwater on site for as long as possible using the green roof, and also by reusing rainwater so as to restrict the consumption of drinking water. The project hopes to set an example in terms of energy performance, but it also wants to stimulate the children's awareness of energy management by teaching them the correct way to use it carefully. This means that sustainable makes up vital elements of the educational project. Some characteristics of buildings. Global value U is 0.18 watt per square meter per Kelvin. Double flux ventilation systems. Very good air tightness of building. Cogeneration, 6 kilowatts in electric and 11 kilowatts for thermic. Sun protection, free cooling, night cooling, bicycle parking, green roof and facade, gardens, fountains, green semi-intensive roof, rainwater tank, 40 cubic meters retained basins, building sign waste sorting, and wall ceiling with acoustic insulation. Key feature: capacity 750 pupils, surface 9,100 square meters. Heating needs 9 kilowatt hour per square meters per year on the school, and 7 kilowatt hour per square meter per year for the gym. This was in design, and we achieve 11 kilowatt hour per square meters for the school and 9 kilowatt hour per square meter per year for the gym hall. Heating with radiators in classroom and other rooms, rapid reaction systems, floor heating in the hallways. The school high performance lamps with electronic ballast, artificial lighting management through light intensity and movement sensor, gym lighting management for training and competition level, and the building management system, centralized technical management system for the building. The concept for instance, there is a section on the construction. We have the hall, and all the systems was put it on the hall, and the class it's very good harmonized with natural lighting. We can see also the isolation systems in the underground, and also the roof, very good isolation systems. Some pictures on the hall, we have floor heating and air handling units from each classroom. We have 60 classrooms, and each classroom are ventilated. We have in each class double flux high efficiency air handling unit, automation of the airflow with the help of temperature and CO2 sensors, ventilation through free cooling and night cooling for a thermic comfort during summer. The quality of the interior climate comfort is paramount for the health and performance of the pupil and children. For each classroom, we made the calculation, and the designer asked us to present some characteristics which in general are the airflow for the systems, supply and exhaust, the heat exchanger, the heat recovery with high efficiency, with a requirement of 80% of efficiency of this heat recovery. The specific fan power for fans, and that there are in the class 2. That was imposed by to be in the class 2 less than 750 watt per cubic meter per second for exhaust and for supply, and of course the sound level should be controlled. And for each classroom we gave this measurement, and finally on the reception we should achieve these requirements. The measurement which was done in execution of this work, and this is the main screen of the building management system, and let's be in connection direct. Now we are in connection with the systems, and we can see what we have here. The order of the ring after each hour of class, it's defined the hour of the ring. Batex, it's exemplary building. We have registered all the metering, the energetic, the thermal metering. We have the for the school, the energy thermic metering, thermal metering for the gym hall, the water consumption, domestic hot water, the gas consumption, and electrical consumption are here. Also, we have the alarms of metering. We have the graph just on time, and we can show all this measurement, which we have also in the table, which I showed before. Let's see only to the shape of the schools are round. If you look the main menu, there are 4 A, B, C, D are the classrooms, and the S is the gym hall. Let's see how we manage for the ventilation system. We are in the classroom, and we can see here we have 290 cubic meters of supply, and the exhaust is 350. From my point of view, here is a problem with the filters. We should change the filters here, and you can see the heat recovery efficiency from 7.9, which is the temperature outside. At this moment in Brussels, we have 19, and the inside temperature it's 22 degrees, and the concentration of CO2 are 666 ppm. Each classroom has radiator systems also for heating, and this is the reason because we have here difference of the supply air temperature and the inside temperature. Yes. Also, the whole for this area we have floor heating, and the temperature inside the hall is 21 degrees now. Let's go to see how work the heating systems. You can the set point is 58 degrees. The outside temperature now in Brussels is 8 degrees. And the next slide shows us the supply distribution for heating, radiators, and floor heating, and also here is the production of domestic hot water with a boiler in condensing boiler. The boilers for the heating are also condensing boiler. Another important, let's see the sport hall, the gym. What we have here, we have the condensing boiler and the cogeneration systems. How I said before, 6 kilowatt for cogeneration is for electric, and 11 kilowatt is for domestic hot water. We have here the supply and the production of domestic hot water for gym hall. Also the ventilation system for the, we have air handling units. How you can see the 2,600 cubic meters, the supply of 2,600 is the exhaust with heat recovery with high efficiency. The temperature, you can see it's around 20 degrees inside, and CO2 concentration 869. From each classroom we have a sensor for CO2, and the air handling units are in function of this CO2 sensor. This is what I can tell you, that it's working, and it was a really challenge for us, and you can see the shape of the. This is a photo from Drona. The four buildings in the round shape, and the sport hall, and I can tell you I'm really proud from what we do that, and it is a reference also from a good practice, being a passive house, and let's say like an eco-design building. Also the shape, this gives the name of the school, Treffler, I don't know how it's in English, but it inspired this shape. I have more 2 minutes. Maria, please. I want to invite all of you. It's the first call for papers for Clima 2019. I can show you this is the website which is working now. The general information are the invitation for the Clima Congress Board, Professor Sorin Burchiu, who is the Dean of the Building Services Faculty from Bucharest, Cătălin Lungu, who is the Vice President of RIVA for the moment, myself, I'm in charge with the sponsor and exhibition committee, and the scientific program, it's managed by the Ilinka Nastase. The registration, very, very important things, the registration fee. We won this competition against the Netherlands, having a business plan with a fee very, very low. comparable with if we compare with what they present, and regular participants registration is for early registration is 396 euro. For member of RIVA it's 366 euro for the early registration. I can tell you also that all the association which with which RIVA has a memorandum understanding have also this fee. We will organize a welcome reception, President's lunch, gala dinner, RIVA course, ASHRAE courses, Romanian Building Services Association courses, and proceeding also. The important dates. First call of papers from December 2017. We invite you to send abstract and papers for us. More details about that in the last session on Friday. Maria will introduce, and it's only to show you that the site is working. You can visit the site, and we invite you to come to Klima 2019. Another important mention, and we have the first diamond sponsor, which is Daikin, and they want to be in charge with the poster session, and a good prize for the winner will be 1 week in Japan in the research laboratory and the research department, and this is the prize offered by Daikin for the winner of the poster session. It's only to encourage the young generation to come and to be present of our Congress. I want to thank you very much once again, and hoping that you will be present in Klima 2019. And let's have next meeting on Saturday and on Sunday. We have a long week being together with our friends from ASHRAE, and thank you very much.
Thank you very much. I see we have one question.
Yes, please.
3 very short questions.
Oh, just one. Because previously I was 3 and it was really
No,
long.
very close. Short.
The answer will be short.
Petr Petrovic from Kotarnica. Is the load that you stated, the 9 kilowatt-hours per square meter annually, calculated for full or for empty?
No, for heating. For heating. It's the condition for the heating, and in relation with passive condition. If you know, the passive condition are less than 50 kilowatt-hour per square meter per year.
Yes, but is it for full?
No, it's for heating. For heating. For full what?
Full building with people, or empty building?
No, it's in function. Yes,
Okay.
for full.
Next question. How long can you do the extraction of the air with a larger volume than fresh air to the building? You stated that the extract air is higher volume than fresh air.
No, this is in the hall. Or if you have this situation that the exhaust is more than the supply, that means we should move we should change the filters, because
okay, that was the case in the slide. And the third question is, why do you go with so high temperature of 58 degrees in heating when you have floor heating? And
the floor heating is only in the hall, and in the classroom we have radiators.
So 58 is for the
Yes,
radiator.
yes.
Thanks.
Okay, thank you once again.
Thank you.